Chapter 12, the two-sample t-test for comparing independent means. When comparing means, we encounter three types of samples. A single sample compares one group to an external standard. Paired samples involve matched observations, like before and after measurements on the same subjects. But in this chapter, we focus on independent samples, where two completely separate groups are compared. Here is our illustrative example from the Western Collaborative Group Study. We want to know whether fasting cholesterol differs between type A and type B personality men. Group 1, the type A men, had a mean cholesterol of 245 milligrams per deciliter with a standard deviation of about 37. Group 2, the type B men, had a mean of 210 with a standard deviation of about 48. The observed difference is about 35 milligrams per deciliter. We begin by stating our hypotheses. The null hypothesis states that the two population means are equal. The alternative can be two-sided, testing for any difference, or one-sided if we have a directional prediction. Now for the test statistic. First, we compute the standard error of the mean difference. This combines the variability from both groups, using each group's sample variance divided by its sample size, all under a square root. Then the t-statistic is simply the observed difference in means divided by this standard error. For degrees of freedom, the conservative approach uses the smaller of n1-1 or n2-1. Let's plug in the numbers from our cholesterol example. The standard error is the square root of 36.64 squared over 20 plus 48.34 squared over 20, which equals 13.56. The t-statistic is 245.05 minus 210.3 divided by 13.56, giving us 2.56. With 19 degrees of freedom, we get a p-value of 0.019. That's good evidence against the null hypothesis, indicating a statistically significant difference in cholesterol between the two personality types. There are two versions of the two-sample t-test you should know about. The Welch t-test does not assume equal population variances. It's more robust and is the preferred method in most situations. The pooled t-test, on the other hand, assumes equal variances. While it's historically important and the basis for ANOVA, it's less reliable when the equal variance assumption is violated. Let's recap. The two-sample t-test compares means from two independent groups. The test statistic divides the observed difference by the standard error. The standard error pools variability from both groups, and the Welch version is preferred because it doesn't require equal variances.